Hi, I'm John Paulraj, and in this video, we will continue to solve question number 1 from paper 3, May 2025, time zone 3 for IB Mathematics, Applications and Interpretations. Let's go. We are on E part 3. E part 3 asks us to find alpha B. We called it alpha B in the earlier question. It looks like A, B, basically the area of the region Q on the diagram. Okay, so we're looking at this particular area, the area of that triangle. Okay, so we want this point and this point if we can. We already know this point. How do we do that is basically this equation that we just found out, 14 minus x for the perpendicular bisector, this one, which happens to be this side, right? That lies, okay, the point of intersection between the perpendicular bisector for SB and this line. I think this line had equation y equals 5, and this one had equation somewhere. It was given in the early part as it given? Give me a second. Yeah, that's the line, 15 minus 2x. So the point of intersection between 15 minus 2x and this one, 14 minus x, and the point of intersection between 14 minus x and y equals 5, all this should give us these 2 points that we're looking for. Okay, these 2 points. Okay, this point is still V. Okay, this is P, Q, and R, talking about those triangles. This point is what I was referring to as V. I thought that was R. Okay, just to clarify, let's just go ahead and use the technique and we'll see how we go through this. How many points is this? This is for 5 points. Looks like a lot of work in this particular question, but let's just go over it. 1E, 1E, part 3. So we want to find the point of intersection. Let's just between 14 minus x and this line. Okay, let's just do that. We can write it down. Point of intersection between 14 minus x, which is y is equal to 14 minus x, and y equals, I think it is 15 minus 2x if I'm not mistaken. 15 minus 2x. 15 minus 2x. And you know what, the best thing is using a calculator. But let me tell you one thing: if you're going to use your calculator to find the point of intersection, especially the graph, okay, you can use the simultaneous equation. You know, you can use the simultaneous equation also to find the point of intersection. I'd rather use the graph, and I'll tell you why in a bit. Okay, but my suggestion is sketch the graph. Suggestion in the sense that that is the requirement for the IB. Okay, sketch the graph. What you see, you got to sketch it. I am not going to do that. Okay, I'll explain what to do. I will explain how to do. I'll explain you the tips on how to get all the points, but it does take time. The videos are getting too long while I'm sketching, so I'll show you how to do it, but you got to sketch whatever you see on your graphing calculator. You got to sketch it on your answer script. All right, I'm not going to sketch that, so I'm going to write here. Okay, sketch the graph. This is considered as working. Okay, so when it says show your working, sketch the graph. Sketch the graph showing the point of intersection, points of intersection. Okay, so let's just jump to our calculator. And here, what we'll do is that we will insert a graph page quickly. So Control Doc and go to the graph page and just write down these 3 graphs. In fact, on one go we can find all of them. So 14 minus x is going to be the line, and don't worry about that line not visible. We'll change the window settings in a bit. Okay, and hit tab, and this is going to be 15 minus 2x. The third line was just the horizontal line, y equals 5. Okay, so you got all the 3 lines there, and obviously we can't see them. Let's just change the color of this black line so that it just I'll make it green maybe. There you go. All of them standing out. Now let's just change the values. This one I'm going to make this something like 17 or 20. Let's make it 20. There you go. Now we can see all of them. Green is my horizontal line. This 15 minus 2x is that red line, as you can see. I hope I can pull the label. Trying to pull it. There you go. That label. I can bring it down here. and this label, I can just drag it here. Okay, let's find the point of intersection. Okay, so we are looking for this point and this point. Okay, and this point is already given. Okay, we've already found this point, this particular point. But let's just find the points of intersection quickly. So we go here and analyze, and say intersection. Got to be careful. We want this graph and this graph. Okay, and there you go. Intersection is 9,5. Just keep it there. Do that again. Intersection between this graph, and there's the point of intersection there, 1,13. As I said, you know, if you can do this without talking as much as I do, then I think you can do faster. Okay, analyze graph. Again, we want to find the point of intersection. This part is already done, but we did it algebraically. Okay, the earlier video we did it algebraically, equating it as 5.5,5. Now this is what I mean. Okay, sketch this graph, label all the lines and the points of intersection. Label all the lines and the point of intersection, and then of course we want to find the distance. Okay, because then that will give us, you know, this, although it looks a little skewed because of the scale, but as you can see in the figure that they've given, this point is what that 1,13 is, and this point is 9,5 here, and this point out here is 5,5, which was already found. Okay, I want you to sketch. I want you to sketch all of that point of intersection between y equals this, and you can also write down and y is equal to 5. You can mention that one also and show the sketch of the graph. Okay, that's working. I'm repeating it several times, and then you can write down as seen, and you can, oh sorry, we need to write using GDC. You can write down the points of intersection. Is it labeled anywhere? Let's just label this points so that, you know, for simplicity it will be good. So we can call this point T. This point is already, you know, V, and we can call this K. All right, just to make references, and you make sure that you've labeled them that way here. Okay, T will be the point of intersection 1,13. Okay, so you can say using GDC T has coordinates 1,13, right? Yeah, 1,13. The V was already found, that was 5,5, but you can show that. But make sure that you mention this T and V was not there. I think V was already there, but we've introduced that letter, so make sure that you write it down. See, these are the tips I wanted to say, right? Rather than just copying down. If you're introducing a new letter, make sure that you've mentioned that on the graph, okay? And then say, okay, that's the point T with coordinates 1,13. TV and K, we have called the point K 9,5, all right? 9,5. All right, now we want from the distance. So of TV using distance formula, you have to show the substitution, all right? 1 minus 5 or 5 minus 1, doesn't matter, it's the square. So 13 minus 5, the whole square. The same way, length of TK would be under root 1 minus 9 the whole square plus 13 minus 5 the whole square. In the same way, length of VK should be equal to under root of 5 minus 9 the whole square plus 5 minus 5 the whole square. That's going to turn out to be 0. I'm just laying it down. We will use a calculator to do the calculation for us, but you know, you got to show the substitution. Okay, hope you can see this. Show the substitution. This is the distance formula. After we find the distance, that is length of each of the sides, then we're going to use what is known as the Heron's formula to calculate the area, right? So area of region R, I believe. Let me just double check that. Area of region Q, sorry. Area of region Q. That's a good thing of double checking. All right, so we can write down using Heron's formula. Okay, this is using the side lengths to find the area of the triangular region. Remember, they've not clearly specified, although it looks like a right angle triangle. In fact, like I said, you know, the calculator looked like a skewed one, but yeah, unless and until it's mentioned, don't assume that it's a right angle triangle to use the formula for half base height. Don't do that. But because we know the lengths, we'll find the lengths, of course. We can use the Heron's formula, which is basically using what's called the semi-perimeter, okay? So once we find this, we'll find the semi-perimeter. So basically, I'll just write down the formula. I'm not sure whether the Heron's formula is given in the formula booklet. So if you have a triangle with sides, let's say A, B, and C, then the semi-perimeter is basically A plus B plus C divided by 2. That's the semi-perimeter, all right? And then the area of the triangle, area is simply the square root of S minus A, S minus B, S minus C, all right? That is the Heron's formula. And that's the formula that we're going to use, all right? And I'll have to find out S first, okay? So I've explained the formula here. This need not be mentioned as, this need not be written in the exam paper, okay? This need not be, I'll just write down what needs to be done. So first, let's just go ahead and find the length of the sides of the triangle, okay, using this distance formula. So jumping back to the calculator, right on the calculator screen, this is of course the graph screen where we graphed that and found all that we needed to find, okay? And so come back to this thing, and I'm just going to enter the values as it is 1 minus 5, 1 minus 5, the whole square, plus 13 minus 5, the whole square. When you're using these things, just be careful, all right? Meaning so many terms are there, entering each term, be careful how you're entering the terms. I'll just go and bring the term down, just make the edit, okay? This just helps to go a little faster. So 1 minus 9, you can just make that, which is why it helps, you know, if you write it down, then you can look at your written work and, you know, and then it'll help you even to enter things correctly, which is why I follow this pattern, okay? So I want 13 minus 5, okay? This is also 13 minus 5, obviously, and so then control enter, and that'll give me the value 11.3 there. And the same way I can bring back that entry, and this time it is 5 minus 9, 5 minus 9, and this is 5 minus 5. Okay, and again I hit control enter. I've got the lengths of all the three sides, okay, and I'm going to show it, okay? This is the whole point of, you know, when you set it up, and then you can just, you know, make those changes. I'm going to write down the lengths of the sides. This is 8.94, and this is 11.3, and this is 4. All right, now using Heron's formula, so what I'm going to do is I'm just going to continue the working here. Let S, and S is already mentioned there, right? So I just write down perimeter, semi-perimeter. Is 8.94 plus 11.3 plus 4, the whole thing divided by 2. Always, this is a good habit so that, you know, you can communicate to the examiner, you know, what you're doing, you know. So I'm just going to pull out these values here now, all right, so that, you know, whatever term was rounded off, you know, the rounding of error is not compounded, okay? And so bring that thing down and just hit enter. Now you get the exact value. I didn't put control enter. There you go, that is control enter. Now half of this should give me the semi-perimeter, okay? All right, so that's 12.2, sorry, 12.1. I'm going to enter that 12.1 here. And then once you find that, area of the region R using Heron's formula is under root of the 12.1, and now this is going to be 12.1 minus 8.94, and you can extend that. This is 12.1 minus 11.3, and then it's a 12.1 minus 4. Okay, so this is a good habit to show the substitution. Okay, you can see this. All right, I hope you can see all of this. Show that, and then once you enter it there, you got the area of that region R. I'm going to write it there, okay, and I'm just going to come here. Be careful how you enter. That's why another reason is also you have something to check when you're entering, okay? So I need that square root symbol again, and this time I'm going to use that term as it is, okay? As you can see, it's a long string and it's rounded off, so it preserves the accuracy. You can get down all the as many digits as possible, okay? Times. Now then put the bracket, get that 12.1 term again, minus each of those terms. So I'm going to go back and recall each of those terms. Okay, so there you go. That was my first side length, bracket, times bracket 12.1 and minus, and then go back again, and the second side length, this one, close the bracket, and times, open the bracket again. Oh, this is going to be interesting. Be careful. All right, so go back and get that. I think it was 4 and hit enter. Now again we hit control enter. When you hit control enter, you'll get the area of the triangle as 16. Let me just check how many digits it is. It's actually 15.99999, you know, rounded off to 3SF is 16.0. All right, so we are going to come back and write this thing as 16.0, and because it's area, we got to write down kilometers square. Clear? This is part 3, 1E part 3. All right, so that was hence find alpha B or AB, whatever that is, the area of the region Q on the diagram. Okay, so remember we avoided using half base height because it's not clear that it is a right angle triangle. Safer side, you've got the lengths, you've used the distance formula to find. Okay, and I've also explained what that Heron's formula is, used it and found out the area of the region R as 16.0, corrected 3SF. If you want, you can mention that also. Okay, 3SF. All right, what's the next part? E part 3 is done. The areas of the regions P and R are given. Okay, that's the area of region, area A and area C. Okay, so that's given as 13.7 and 6.9 kilometers square respectively. Use the natural neighbor algorithm to show that an estimate for the expected AQI value of the school is 94.4. The formula is given, right? The formula is given here, and we are actually just substituting. And again, make sure that you're showing all the substitution, okay, and that it is correctly substituted. So where can we do that? Can we just continue down here? Let's just put a line here, okay? A line here, and this is 1F. So we are going to write down 1F. Copy down the formula first. Let me just take a look at the formula. This is WA AA. That's why, because of the AA thing, I was getting confused, so I called it alpha A. It's AA, AB, and AC. WA, and the T, what is the T? The T is the total area. The total area. So basically, it's a sum of alpha A or AA plus AB plus AC. All right. So let me just write down this formula first, and then I can work out the substitution. So basically, this is WA AA plus WB AB plus a WC AC over T, but we know that the T is basically AA plus AB plus AC. All right. So now let's just put on the values. WA, WB, and WC are given in that table. They'd already given the table. That was the index, right? This is, yeah, the mean AQI. So 132, 49, and 125. 132 times AA. They have given us AA as 13.7. Where did I write this? 13.7 plus WB is 49 times AB is what we just calculated as 16.016. This is AB, all right, the area. This is 16.0, and then WC is 125 times AC is given to us as 6.9. 6.9. And the whole thing divided by T, which is basically AA plus AB plus AC, which is 13.7 plus 16 plus that 6.9. Okay, make sure that this substitution is clearly shown. Okay, then obviously you can enter into the calculator as I've already done. But this part is important that you show this part. Let me just check whether I've entered the values all correctly. Okay, 132. Yeah, I think we've got everything right. Now it's all about putting it on the calculator. Okay, to calculate the value of W. Let's just go back there. Okay, and we need the template for the fraction. So let's just go and let's control this one, and 132 times 13.7 plus 49 times 16 plus 125 times 6.9. In the denominator, we've got 13.7 plus 16 plus 6.9. All right, did I get everything correct? I think so. Okay, let's just hit Control Enter, and we can see that it's 94.5. I think that's almost exactly. Let me just see the 3SF what it is. 94.4. Yeah, pretty cool, huh? So we got that as 94.4 as required. Okay, I just wrote it down here, copied it down to 94.4. All right, 3SF. Again, we can mention that this is up to 3SF. 90 that's what we wanted, right? To show that it is 94. There you go. It's spot on. Okay. The principal is still concerned that this method is underestimating the AQI value at the school. Wow, this principal is amazing, you know, an amazing mathematician. As the school is situated close to a busy traffic intersection. So obviously she's concerned about the pollution level there. There's too much traffic happening there. And so she's saying, you know what, this is still underestimating the expected AQI is 94.4, and apparently she's saying it's still underestimating. She decides to take her own readings, X, over a period of 60 days. Good for her. Her results are summarized as this. That's the sample mean, 97.8. Okay, and this is the sample standard deviation, Sn-1, 17.2, and N is 60 over a period of 60 days. The principal assumes that the daily AQI values at the school can be modeled by a normal distribution. Okay, that's the assumption made, and that each value is independent of any other values. So yeah, every other day the values, they're not dependent, they're independent values. G is what we are at, and it says test at the 10% significance level the hypothesis that the mean AQI at the school is greater than 94.4. So we want to test that the mean AQI is greater than 94.4. State clearly the null and the alternative hypothesis and the conclusion of the test in context. It's out of 6 points. Okay, it's out of 6 points. So make sure that this part is written very clearly. All right, and whenever you write the hypothesis, remember you should write it in terms of the population parameter. Okay, although it's given as X bar, you've got to write it as population parameter, and the null hypothesis is always the status quo. So we will say that it is 94.4, but you know, the alternative is claiming that it is greater than 94.4. So where are we? I'll just continue here. G. Okay, so question 1G, null hypothesis. What test? What test? The test is, we need to say what test are we going to use, right? We're going to use the t-test, and they've not explained clearly why, because we are using a t-test is because we don't know the population standard deviation. All right, we don't know about the population variance, in other words, we don't know that. So we are going to use the t-test, and let's just say that, okay, using t-test, as we do not know the population variance. And so the population standard deviation, either one, you know, should be mentioned, and hope this is clear. We're using the t-test, and the null hypothesis is always written in terms of the mu, right? That is what I meant by population parameter. This is going to be equal to 94.4, okay? And alternative hypothesis, we want to claim that it is greater than 94.4. Okay, let's just check. I think that's what we want, right? It says the school is greater than, yeah, the mean AQI value at the school is greater than 94.4. This is clearly said. And then what do we want? We're going to use the t-test, and these are the values, right? These are the values that's given, right? So let's just go ahead and use the t-test with these values. I'm going to run to my calculator quickly, and here we are. Let's just enter a new page because there's so much drama happening, okay? So I'm just going to enter a new calculator page, still a calculator page, but it's just clean. But at the same time, remember why am I giving this tip is that even there's so much happening, when you're checking your work, it's still there. You're not, you know, you're not deleting everything. You're not deleting everything. So just enter another calculator page. That way, all the working is there. All right, let's just run through this thing now. Statistics, we want to run a t-test. And we are going to, the input method is not data. There's no table of values. There's stats, okay, that X bar and that Sn-1, whatever was given. Okay, mu naught is going to be the 94.4, okay, and X bar, they gave us X bar as 97.8, and that Sx is what that value you're going to enter. This is a sample standard deviation, okay, is the value 17.2, and what do we have next? N is 60, n is 60, and our alternative said that it is greater. Okay, okay, it's greater. Okay, so if this is all clear, okay, make sure that you copy this down. Again, when you say using GDC, you should copy this down, and I'm just going to do that quickly. So using GDC, and since we've already said, you know, using the t-test, even then if you want, you can just enter that here. So you can say t-test, just copy down what you see, or basically the inputs, how you see on your calculator. Okay, so on the calculator it says mu naught, so you just going to enter it as mu naught. You don't write it as mu naught, okay, you should write it as mu. And then you have x bar is 97.8, and what is this, sx, remember they gave it as sn minus 1, okay, so but you're just writing how what you see on the calculator, basically 17.2, and then n is 60, and what do we have, alternate hypothesis is basically mu is greater than mu naught. Okay, so we have entered here what is it that you've put on the calculator. Basically this is just showing the examiner what you've input into the calculator. Cool. Running to the calculator again, and we say okay, and it is obviously giving us an exact figure, so let's just go and make this approximate. Okay, don't freak out when you see this, you should know what's going on, all right, so that you can change the settings and run it again. Okay, so we can just bring that value down, and you can just say control enter. You'll see the same table now with approximation. So we have the t statistics and the p-value. We're interested in the p-value, right? So we can say the p-value is 0.066, okay, and we can come back to our then we will see, I think, is it 5% or 10%? I thought, yeah, tested the 10%. Can you see that? Be careful, okay, because we are so used to 5% significance level depending upon what's given. Okay, you're testing it with 10% this time. So 0.066, if it was 5%, of course, you know, you'd have said that you have sufficient evidence to reject, but now, sorry, 0.066 with a 5%, you'd have said we do not have, okay? It'll be a different scenario then. So we can say since p-val equals 0.066 is less than 0.1, this is your significance level. So it's not 5%, it's 10% this time, right? So since it's less than 0.1, then you make the conclusion, and you say since this is less than, we can say that we have sufficient evidence at 10% significance level to reject H naught, the null hypothesis. What is the H naught? H naught said that mu, the mean AQI is 94.4. Okay, so you're going to reject that, but don't say that you're going to accept. Okay, so because it says you have to explain in the context, conclusion in the context. Can you see that? So you have to use those words. The context was that the mean AQI value at the school is greater than, right? So we'll say that we have sufficient evidence at the 10% significance level to reject H naught, which means that we have sufficient evidence at 10% significance level to reject the claim that the mean AQI near the school is 94.4. I think that is how you should conclude. That is how, because we don't say just because you reject, we don't say we accept. That is not a good That's not statistically correct. Okay, we just say based on the sample, based on the significance level, we reject. Okay, rejecting the null does not automatically mean that we're going to accept the alternate hypothesis. Okay, so it just means either we are rejecting or we are fail to reject. Okay, so we are rejecting is what you're saying. H, let's just complete this, even though this video might seem a little long. Okay, let's just complete this question. The principal now assumes that the distribution of AQI values at the school follows a normal distribution with mean 97.8. 97.8 is that value that she got from those 60 days, right? And the standard deviation is 70.2. Okay, so she's now assuming that that's like the population mean. Okay, so it's following a normal distribution with 97.8 mu. Standard deviation 17.2 is what she's saying. Use this model. This model means this normal model to find the expected number of days per year. How many days per year? Correct, to the nearest day on which the AQI value can be classified as good. Remember, somewhere in the question they said that it's classified as good if the AQI value is less than 50, right? At the start when they explained. Can you see this? In this district, values less than 50 are taken to indicate the good air quality. Yeah. So if it is less than 50, the air quality index AQI is good. So what is this saying? That using this model. So let's just say, I'll just write the answer here. Okay. So this is 1H anyway. It's written here. Question 1H, and it says that we are going to model this X is a random variable with normal mean as 97.8, and sigma square is what we need to write here. Remember, it's a variance. Okay, so make sure you write that thing down, and we can say that the probability of X being less than 50 is what we want to find out. You understand why less than 50? Because then only it's classified as good. We want the expected number of days, remember? So once you find the probability, we'll multiply this by 365. So using a GDC again, so let's just write that phrase down using GDC, and we go to the calculator one more time, and this time we're going to use normal CDF, probability and distributions, normal CDF, and the lower bound is going to be any large negative number, so negative 10,000 is good enough. Okay, and the upper bound should be 50, and the mu is 97.8, and the sigma is 17.2. Okay, so make sure you copy this down. Always, it's a good habit to show the examiner what is it that you have entered. All right, so I'm just going to show that quickly. Switch here, normal CDF, and this is lower bound is negative 10,000. Upper bound is 50. Mu is 97.8, and that sigma is 17.2. All right, so coming back to the calculator, we just hit Enter. Okay, and it gives us 0.003. Let's just bring that thing down. 0.00273. I'll write it as 0.00273 because that is the 3SF. Okay, this is not 3SF. 0.003 is not 3SF. 0.00273. See, even though this settings is 3SF, okay, that is why I do this all the time. I think I've referred to that in an earlier video. Okay, I'm going to write it as 0.00273. Okay, and so this value is 0.00273. Perhaps this using GDC should have been written before. Okay, so using GDC, there you go. And this explains how we use GDC. Now, this is not the answer. Remember, we want to find the expected number of days. So then we can write down, therefore, expected. Or we can write down required. This phrase is really helpful. You can write down required expected number of days is basically that probability that we just found out, 0.00273 times 365, because that's many number of days in a year, remember? And so when you do that, let's just see what we get. So I'm just going to come back to the calculator now. We have this value here. We have this value, and this is multiplied by 365 to get us 0.995. Oh, this is days, right? Let's just check that out. Yeah, 0.995. Okay, so we come back and we say this is 0.995 and to the nearest day. So this is really funny because the expected number of days, if you're going to assume this, the number of days that the AQI value can be considered good is just 1 day. Can you see that? Wow. No wonder the principal is getting so paranoid. So with that, we complete this question. I know this video has gone too long. That's all the time that we have. We will continue with question number 2 in the next video. All right. If you found this video useful, please make sure that you like, you share this video with a friend and subscribe to my channel. If you visit my channel, there are plenty of other videos there. Do check them out. And if you want any question, any concept, any topic explained, do mention that in the comments and I will make a video for you.